is a common base. So in this example, I cannot get 20 to be a base of 3. So I'm going to do method 2, which is taking logarithm of both sides. So what I mean by that is I'm going to take the log of this side and the log of this side. As long as I do that, I'm keeping my equation balanced. Log of 3 to the x equals log of 20. So now I'm going to use my properties of logarithms, which states I can take my exponent and bring it down to the front. X times log of 3 equals log of 20. So now my next step to isolate my x is to divide by log of 3 on both sides of my equation. It'll cancel out. So x is log of 20 divided by log of 3. Log of 20 divided by log of 3, which is approximately, let's say, 2.7, round to the nearest 10. 2.7. So I know 3 to the 2.7 power should be 20. Let's check. 3 to the 2.7 is going to be approximately 20, right? But if I do 3 to the 2.726833028. 028. Let's see what that looks like. 20, exactly. So we should probably write that entire decimal out. 2.268333028. It's a better answer there. Unless I tell you to round, which I didn't do. Okay, so once again here in example 2, I can't write 20 as 5 to some power. So I'm going to do method 2 to solve this exponential equation, which is to take log of both sides. Log of 5 to the x minus 2 equals log of 200. Now remember, these logs are just base 10. Log base 10 is stored in our calculator. So now I'm going to use properties of logarithms to take this exponent and move it down in front. So I have x minus 2 multiplied by log of 5 equals log of 200. So now remember, my goal is to solve for x, to isolate x. Now I don't want to distribute this log because it'll make it more difficult. So I'm going to divide by log of 5 on both sides to cancel. So now I'm left with x minus 2 equals log of 200 divided by log of 5. So my last step to isolate x is to add this 2 over to this side. So x equals log of 200 divided by log of 5 plus 2. So I'm going to plug that in my calculator. So it's going to be log, where's my log? Log of 200 divided by log of 5. Let's see what that is. And then add 2. So 5.292029674. So I'm sure we'll round to the nearest whatever I tell you to do on the homework or a test. Okay, let's try one more of these in the, let's continue on with this. Why not? So here we go. Here's another example here. We can't write 15 as 2 to a base. So to solve this exponential equation, I'm going to take a log of both sides. Properties of logarithm states I can bring my exponent down in front. So I have 3x times the log of 2 equals log of 15. Well, to isolate my x on this side, I need to divide by 3 log of 2. Divide by 3 log of 2. So my 3's will cancel, and my logs of 2's will cancel. So x equals log of 15 divided by 3 log of 2. Log of 15 divided by 3 log of 2. 0.118. I'm going to round that. 0.118. All right, great. We'll be solving these types of equations in class tomorrow.